Hi everybody and welcome to this introduction to Android Wear talk, a glimpse into the future. So be brave, the weekend is almost here, so you're almost ready. So let's start with a quick introduction about myself. So my name is Cyril Mottier and I'm an Android Google developer expert. You can find me on Twitter at Cyril Mottier or on my own website where I usually blog about mobile-related stuff like UI, UX, and how to create nice UX on mobile. And I'm also in charge of all Android-related projects in a company called Captain Train, but I know you know it, right? You used it to come here, right? So basically, Captain Train is a company that tries to revolutionize the way you experience train. So we basically sell train tickets, of course, but we also try to enhance the trip experience. And we are doing that on several platforms. The first platform, of course, is the web. But as I said, I'm in charge of it after all. So we are also available on mobile, Android first, and also iOS. And more recently, we've been releasing a new application, an application for Android Wear devices. And this is actually the reason why I'm here today, because this talk is kind of a feedback on my experience at developing this application for Android Wear. So I think the most important thing to understand about Android Wear is why we've had the necessity to create something different from what we have on phones and tablets. And we will do that in this introduction just by, stepping back from what we currently know about mobile and tablets, and by analyzing how your everyday life can be summarized. So I've thought about it, and if you think about how you use your phone in your everyday life, it can be summarized like this one. Well, you live your life, and I don't know, you want to check out your email. So first what you have to do is, to get your phone. Sometimes your phone is in your pocket, sometimes it's in your car, sometimes it's on your desktop. So it depends, and you may spend some time just looking at your phone. And once you have it, you start using your phone and you look at your emails. But because the phone is quite distracting and there is lots of apps on the phone, you may try to exit from the email application and start looking at something else, like, let's say, your favorite news application. And once after that, you go back to your everyday life. And this pattern is actually repeated over and over again throughout the day. And Android Wear is here just to try to reduce those interactions, this get phone and use phone spans of time, just by reducing those spans. So when you want to look at your Android Wear device, most of the time a watch right now, you just have to look at your wrist. Well, I wear my watch on my wrist. I don't know where you wear it, but I don't want to know about it. But basically, when you want to get your Android Wear device, you just have to look at your wrist, and then you can use it. And it's less distracting because Android Wear is really focused, and it also only displaying information that you really needed. And this pattern, once again, is repeated over and over again. So the principle here is that Android Wear is about micro-interaction. It's about reducing all those tiny interactions throughout the day to their minimum. Another thing to understand is that the grid of apps paradigm that you know and you use every day on your phone doesn't apply well or at all actually on wearables. It doesn't make sense to apply this paradigm. So this, just a sum up, just to explain what this grid of apps paradigm is that you have a home application which contains a grid of application like those tiny icons. When you click on one icon, it opens a full screen application. And once you want to go to another application, then you exit the app, you go back to the home, and you start pressing another icon. And this doesn't make sense actually on wearable, because paradigms for handheld devices are totally different from what you would expect on a wearable, where interaction is difficult or not great. So I think what you have to think about is, well, to think different. So I've put this, but actually I think it's patented, so let's say think differently, which is more grammatically correct. And this is something that you always have to keep in mind when creating application for Android Wear. So now let's continue on the UX point of view. So now that we know that we have different paradigms between what we can find on tablets or phones and on wearable devices, we can deep dive into UX principle. So I've thought a lot about the main principle of UX on Android Wear, and I came up with 3 main principles. When you create an Android Wear application, you have to make sure that your application is contextual, that it's glanceable, and finally that it requires like low interaction or even better no interaction, because, well, it's even better if you can do without asking the user to interact with the wearable device. So let's start with contextual. Well, contextual means basically to provide just the right info at just the right time. So I think the best example of that is the weather application. Well, actually there is no weather application. This is Google Now. So there is a weather card that is displayed by Google Now on the wearable device. And here it's pretty contextual because I've created those slides at my place, at my home in Lyon, in France. And it's basically showing me the weather from Lyon. And just by using my current location. And what's nice about this weather card is that like 4 days ago, it started to show me another card for another city, which is Antwerp, because Google Now knew that I was coming to Antwerp. And the card was like, instead of the sun, it was just some fog. So I don't know why. I asked if it was a bug, and the people from Google Now said, no, it's hard-coded. So now, how can we, try to merge all of those information that we have on mobile to make things contextual? Well, we have plenty of sensors and plenty of helpers to do that. First, you can use the time. The current time, for instance, may be a great, evidence of what you can display to the user. For instance, it makes no sense for the DevOps schedule application to display that you have to go to this session at midnight, because normally there is no session at midnight except in the bar. Then you can use also sensors like the heartbeat sensor. For instance, you can display more information when you know that the heartbeat is high, because, for instance, it probably means that the user is actually doing some exercise or, walking or running. You can also use the calendar events of the user. There's also some APIs that are provided as part of Google Play services, and those APIs are known as activity recognition. So those APIs basically tell you that whether you're walking, running, biking, or even riding with a car, which helps you, to change the way and change the information that you're displaying to the user. You can also use the identity, the location of the user, which is something quite easy to do. You just have to get the location and present some information based on the current location. And you can even know about nearby devices and adapt the information based on the nearby devices. The second thing to keep in mind is to have something which is glanceable, an application that is glanceable. And being glanceable means only displaying the essential information and doing that in a blink of an eye, so that the user can parse the information like in 1 second. And I think a great example of that is the Google Maps application. Here, well, you've probably never seen this screen, and actually you can understand it like right now, just looking at it. Actually, it means it's the Google Maps application displaying me that I have to walk for 150 meters on Courviton, and that my estimated time of arrival, will be at 12:24. And this is, well, fairly easy to understand that I'm in navigation mode and that I just have to do that. So in order to understand that, I've created a mock-up, a fake Hangout application that you can find on the left. And the one on the right is the official one. So this is my wife telling me that I have to smile during my talk, but tell her that it's not easy to smile when you're talking. And the one on the left, well, is something that contains more information. So if you start, stepping back and start counting all of those information, you can see that there is lots of information on the left. You have the text, a title describing which application sent the message. Then you have the name and the photo of the sender. Then you have another title to explain you that this message has been sent at 7 o'clock. And finally, you have the message. And if you start looking at the one on the right, well, you have less information and it's bigger, it's easier to see. And I'm sure that here you don't really notice which one is easier to parse or to understand or which is more glanceable. But if you start thinking about the fact that you may be moving when you're wearing an Android Wear device, then I'm sure that this time you better understand the one on the right first, because it contains less information and it contains just the right information. And finally, Android Wear application should be about low interaction or no interaction. So this is a friend calling me this weekend. I took this screenshot this weekend. He wanted to talk to me about an article on Medium. He's a blogger on Medium, actually, talking about internet and neutrality. And here, this is actually the phone application. And what the phone application does is that it displays a very simple screen that requires low interaction, or if you want, no interaction to the user. What you can do here is that you can swipe from the bottom to the top to, send a text message to this friend. So, for instance, you can tell him that you will call back right after that, or you can swipe from the left to the right, and this will hang up the phone call. And what's actually quite nice about this is that in the first version of the application, it was also possible to reply, by swiping from the right, to the left. And this has actually been removed because it makes no sense to reply on a wearable, because it's not a phone. A wearable only tells the phone that you can reply. So basically, if you don't have your phone right with you, it means it makes no sense to reply. So this is really about low interaction. And all of those interactions are actually designed for big gestures, because a wearable is small. So let's move on. I will call him back this weekend. And another example of that is the calculator application. So I've created a fake calculator application for Android Wear, and this looks kind of nice. It's material design, it's fancy, it's gorgeous, it's amazing, it's bold, blah, blah, blah. And if you think about that, if you start realizing that actually a wearable device is not that big, then you end up with some issues like that. If you want to, let's say, do an addition, chances are you will not tap the correct button, because your finger is like half of the screen. So basically, it means that when you're creating Android Wear application, you have to make sure that you favor non-error prone inputs. And that means basically to use full screen taps or swipes, or also voice action, because this requires no physical interactions. And there is another point actually, which is that there is no input methods. It makes no sense to have a keyboard on a wearable for the exact same reason, because your finger is like as big as the screen itself. Another thing that is different from what you have on phones on a wearable is that the activity lifecycle is actually simplified. And by that is that when you put your device in sleep, well, the activity is actually destroyed. This is not the case on phones, because let's say that you're going to the browser, then I don't know, you want to go somewhere else, so you make you turn off your phone, and when you go back to your phone and start it again, then you're still in the Chrome application. This is not the case on wearable, because when you're doing that, just by putting your hand on top of the wearable device, it will destroy all activity. So that actually you going back to the home activity, and this is because Android Wear is really task focused. So when you start a task and exit, then it probably means that you're done with this task, and it means nothing to come back to this task. So this is something that is different from what you could expect on phones. And it basically means from the technical point of view that you will be destroyed. So the on, stop, and on destroy method will be called in your code. And finally, the thing that is different from what you could expect on a phone is that you have to think your application as a row in a grid, as a row of cards, in a grid. And I've done a tiny animation to explain that. So this is how Android Wear works. So you have a column of cards that are displayed. So each card represents an application. So for instance, at the top we have the Hangout application, and then we have the player. And you can swipe, like that, to change the application that you want to be notified about and see the notification about this application. And when you want to have more information, you can swipe from the right to the left, like where it's not done in the animation, but here you have the Google Now for Flights cards that you can swipe, and you have more information when swiping to the right. And if you're swiping to the left, then like this, it will remove the notification because you're done with it. And that's it. That's fairly simple, but there is no grid of apps. This is more a grid of cards displaying informations. So let's now continue on. Now that we're done with the UI and mostly the UX point of view, that we understand that Android Wear is completely different from what we are used to on phones and tablets. Let's deep dive into a more technical point of view. And the first thing to understand is that when you have a phone and a wearable, well, you always have one operating system per device. And that basically means that you have no shared code whatsoever or no shared resources. So what you're doing on the wearable is actually not executed on the phone. And what is executed on the phone, of course, is not also executed on the wearable. And having no shared code and no shared resources basically mean that you have different code base and different applications. So if you want to create an application for Android Wear, it has to be a different one from what you have on the phone or tablet. So how do we communicate between those devices? Well, actually, this is done thanks to Google Play Services. So Google Play Services is a framework that is available as part of Android, but it's actually updated automatically by Google so that you don't have to wait for system updates. This is the good point about that, and it's updated back to Gingerbread, I think, if I remember correctly, or Froyo now. And what it takes care is basically to handle the transport layer between the wearable and the phone. And this is done actually internally using Bluetooth low energy. And whenever you want to transfer some data between the wearable and the phone, then you have to go through the Google Play Services API. And we'll see later what kind of API we have access to. Another funny thing to understand here is that actually you could also imagine doing your own, communication between the wearable and the phone, but this is not recommended because basically it means that you will have, different types of communications. Please rely on Google Play Services instead, which can be updated when it's, not secure or when Google wants to improve it. And finally, how do we install application on Wear? Well, actually there is no Play Store or on Android Wear because it makes no sense. Once again, as I said at the beginning, interacting with a wearable device is like, you know, disgusting almost. You don't want to interact with it. So what it does instead is that it makes APKs containing other APKs. So how do we distribute that? Well, whenever you want to download an application on your wearable, what you do most of the time is just to download an application from your phone, on your phone from the Play Store. So you get an APK, which gets installed on the phone. And once it's done, the phone will automatically push the imbricated APK to the wearable devices that is connected to your phone. And this is done automatically. You have nothing to do. From a user point of view, this is completely transparent. You have nothing to do. And this is done fairly rapidly. So whenever you're installing actually an application from the Play Store, well, instantly it's replicated on the wearable device. So now we're in a tech conference, so let's deep dive into how to create a wearable application, Android Wear applications. Let's start developing for Android Wear device. So when you come to developing Android Wear for Android Wear devices, you have actually two possibilities. The first one is notifications, and the second one is to create a completely custom application because, as I said, well, you can't share a code between the Wear and the phone device. So if you already have notifications in your application, then you have nothing to do. And this is because if you step back and start thinking again about the 3 UX principles that I've explained, you will notice that notification are the perfect feature that are currently available on phones that could be replicated to wearables. Why? Because notifications are actually contextual, very contextual. They are also very glanceable because they display only small pieces of information. And they are low interaction because in a notification you can display like, I think it's 3 actions plus the main action. So at a maximum of 4 action. So when you're doing that, the system will actually automatically push your notifications that are displayed on the phone to the wearable. So you have nothing to do. And this is, you know, you have it for free. Well, almost actually, because when you're doing that, it's working, but you can tweak it to make it better for a better wearable experience. So let's deep dive into the code. So this is, I think if you're used to Android development, you will find this code quite easy. Here I want to create a notification in my notification tray. So what I do is I create an intent that will be actually the intent that will be used when pressing the notification to get back to the application. Because I can't pass intent directly, I have to create a pending intent, which is like a future intent that is used by the system. And then I start to create my notification by using the notification compat.builder API. And what I do here is that I set a small icon, so I pass the application icon, then the content title, then the content intent. And finally, because I want to have lots of text in my, not a lot, but more text than usual in my notification, I create a big text style notification. So it's basically a rebuilder, so the text builder, but it's a builder, that text builder. And then you call build on it. And then once you're done with the notification, you can, well, pass it to the notification manager so that it can display it on screen. And this is what it does. So on the left you have what you have on the phone, which is, well, the notification as you know it, and automatically, as I said, the system will push the notification to the connected wearable devices. So here is what we will have at the exact same time. We have the exact same information. The UI is kind of different, but the information is exactly the same. And when you're looking at that, well, the one on the left is clearly more fancier or nicer to look at. So the one on the right could be actually enhanced. For instance, the gray background is not that nice, and it's actually computed automatically by the system based on the colors of your application icon. So I think we could, improve that. For instance, the green here provides no information, actually. It would be better to have an information or an image about the town where you're going. So, for instance, here, my trip is from Lyon to Paris. I think it's better to display an image from Paris because I will be able, to understand where I'm going in a blink of an eye, the glanceable principle. And this is possible thanks to some classes that are available as part of the Android support library. And this class, the main class that you have to use is the wearable extender, which comes to the rescue because it lets you define some wearable specific features for wearable notifications. So let's get back to the code. I want to change the background. So what do I do? Well, that's simple. I just get the image from my resources on the phone. So yeah, just one quick note here. Everything that I'm displaying here is actually some code that is run as part of the phone because I'm using the notification on the phone, the notification API on the phone. So here I get the r.drawable.paris drawable, and I get a bitmap with it because you can't send a drawable directly. You have to send a bitmap. And then once I have it, I create a new wearable extender. I set the background to it, and I extend the builder, the previous builder, the notification builder that I had, with this new wearable extender. And boom, this is what I have. Fairly easy, just 2 lines of code, and I now have a notification that looks great on wearable. So this is something quite easy, but actually you can have access to some features that are only available on wearable, such as stacks. Stacks are pretty awesome when you want to notify the user with a lot of notification from your application. For instance, in Gmail, you can have like 6 emails, and you will have 6 notification on the wearables, which is kind of a pain in the ass when you want to remove all of those notifications. So instead, you can set a group on it. And by setting a group, which is basically a string, the key of the group, the notification manager on the wearable will automatically collapse all of those notifications into one single notification, displaying like this, plus 5 more. You can also set a sort key if you want to sort all of those notifications inside the wearable notification tray. And finally, you can also set a boolean on a notification that are part of this group to say to the system, well, this notification is the summary of all of those notifications in this group. So if you want to create a notification that resumes or sum up all the notification, you can use this method. So stacking notification is, really important for the user because it prevents him or her from having to dismiss a lot of a notification at the same time. You can do that once. And when you click on a stack, well, it expands and it displays all information from all of those notifications. Another interesting feature is pages, because displaying lots of information on a wearable is not nice because we have a small screen. So basically, we can try to split information into different parts, and this is done thanks to pages. So you have only one API, which is extremely simple, which is called add page and text a notification. So basically, you have a notification, and you can add pages or the notification to this to this notification. And this will be displayed like this, with some dots, page indicators at the bottom, and you can swipe, on the notification to have more information about the notification that is currently displayed on screen. And finally, you can also have access to some remote input or voice actions. This is fairly nice because, as I said, when you want to reduce interaction between you and how you interact with the wearable device, talking is probably better than just doing a gesture like a swipe or a tap. So let's say that you want just to have an answer to a yes or no question, then you can use the remote input, because you can use the set choice on this object, which requires you to pass an array, and you can pass an array containing yes or no, and then the remote input will only look for yes or no, and will send that back to the phone, so that your app can interact or reply or to the answer that the user has given. But there are some cases where, we have lots of notifications, features, nice tags, voice input, pages, but there are some cases where notifications are not enough. And for instance, this was the case for our application. Because if you look at that, what we can have with notifications API, well, you have lots of text, but we wanted to have something more simple. Simpler, and we also wanted to display the barcode that you have to present to the train agent so that it can scan your code and verify that you have paid for this ticket. And displaying this barcode requires actually two important things. The first is that you have to make sure that the screen is kept on, because you don't want to show your wrist like that and the wearable to switch off, especially when you know that when it's switched off, it goes back to the home. And you want also to have an application that displays the barcode in full brightness, because if it's not full brightness, then sometimes the train agent can't scan it. And, well, you can't do that with notification. So you have to find another way. And this other way is actually creating a completely custom application for Android Wear. And when you do that, well, you start looking at the documentation, and you end up realizing that actually wearable applications are fundamentally the same as applications that you're used to do on other devices. Because it's Android Wear is actually Android. Right now it's KitKat, which is the exact same, almost the exact same KitKat that you had on phones and tablets. So if you're used to Android developments on phones and tablets, then you will be used to development on Android Wear. There is actually some tiny differences, which are that there is some unsupported APIs. So for instance, you don't have access to WebKit, because actually it makes no sense to have a browser on a wearable. You don't have access to the network on a wearable. You don't have access to a browser on a wearable. You don't want to interact with the wearable, to look at a web page. So it would make no sense to have WebKit on a wearable. And then that's the reason why you don't have access to this API. You also don't have access to all print APIs or backup app widget, which are the widget that you can have on a launcher, but you have no launcher on a wearable device. So it would make no sense to have the access to these APIs. And finally, you don't have access to hardware.usb, because a wearable device doesn't have USB. So basically, it means what? Well, it means that it's exactly the same. So if you're creating, you know how to create an application for tablets and phones. You know the principle of services, activities, and views, and broadcast receivers. All of that is available and used on wearable application. The only thing that you have to use, if you want to make sure that the feature is available, is to call the hasSystem feature method on the package manager, if you really want to make sure that the API is available on your code. So now that we know that it's actually pretty much the same between wearable and phones, how do we communicate between those devices? And there is actually 3 different APIs for that are part, as I said, of Google Play services. So the first one is the Node API. The Node API is a very low-level API that lets you know about the nodes in the network. So what is a node? Basically, a node is a device. So a wearable is a node, and the phone is a node. If you have some glasses, Google glasses, it will be also a node in the network. So all of those nodes create networks, and if you want to know about those nodes in the network, you can use the Node API. Then you also have access to the Message API. And the Message API is basically an API that lets you send some message from the wearable to the phone or from the phone to the wearable on a fire and forget basis. So it means that you're sending it to the, for instance, the phone is sending a message to the wearable. If there is no wearable, then there will be no callback to the phone, so that the phone knows that the message has been sent or not, or has been received or not, sorry. And if you want to have, this feedback about the fact that a message has been sent or not, then you can use the Data API, which is most of the time the API that we will be using when creating wearable application. Because it's like the Message API, but instead of just working on a fire and forget basis, it will actually sync data between nodes in the network. So even if the wearable is not connected at the time you're sending the message, it will actually store the message, and once the wearable will be back online, the message will be sent to the wearable. So now that we know all of those APIs, let's go back to our example. So we had a notification, we want to display it on the wearable. So first, instead of using the notification API, now we will do that manually actually. And in order to do that, well, we have to start back on the handheld application. So in my service that it was actually firing the notification, I will set a flag to my notification, which is set local only. And what this flag tells to the system is that do not replicate this, this notification on nodes in the network. So when I will be firing this notification on the phone, it won't be synced to other devices on the network, so that it's not displayed on the wearable. So this is just one line of code, and we are done with the creation of the notification on the handheld device. Now instead, what we have to do is to use another way of sending data to the wearable, and this will be done thanks to the Data API. And in order to use the Data API, you have to create a Google API client. So this is kind of boilerplate code to do, but this is what you have to do whenever you want to use Google Play services. So here what I do is, if I don't have a Google API client, sorry, I simply build it by passing the API that I want to use. So in my case, I want to use the wearable API. And then I pass some on-connection failed listeners and some connection callbacks that will be called when the connection has failed or suspended or succeed. And once I have it, then I connect. I connect this API client. And when it's connected, I will be called back in the connection callbacks dot onConnected method. And this is where the to-do is, because this is where I will actually send a message to my wearable device. So let's look at the onConnected method. So what I do here is basically to create a bunch of data, a bundle of data that can be sent on top of the Data API. So the Data API is very low level, actually. It's basically you can send an array of bytes. Fortunately, the framework comes with some magic, well, not that magic, but some helpers to send you some data, so you can send some integers, long strings, all of those like primitive types from Java. So what you have to do here is to first create a request, because you want to send some data map to the wearable. So you create a request which requires you a URI. So the URI, sorry, is like the path to your, a unique path to your data. So here what I want to do is to show reminder, and the notification ID will be, the ID from this, notification will be travel. And then I get the data map from this put data map request. And once I have a map, I can put data in it. So data are stored thanks to on a key value basis. So here I want to pass some data like the departure station, the arrival station, the barcode data, and all of the time at which I'm living, etc., etc. The seat where I have to sit, the carriage, and stuff like that. And once I have my data map prepared, I can send it to the wearable. And this is done thanks to the wearable API, data API. API, put data, and more specifically the put data item method, which requires you to pass the Google API client, because we've created earlier, and then you pat the put data map request, and you can set also a result callback to make sure that the information has been correctly sent to the wearable. And if it's not sent correctly, then you can deal with errors. But it's not, compulsory. You can do whatever you want. So now the data has been sent to the wearable, and we're done on the handheld side because we have nothing else to do. The notification is displayed, and the data useful for the wearable device to display a notification has been sent. So now the counterpart is actually on the wearable device. And on the wearable device, you have to listen to some new data map items that are received. And this is done thanks to the wearable listener service. So this is a service that is actually part of Google Play Services, and that gets started when a new data map or data event gets received on the wearable device. And when it gets started, you are called in the onDataChange method. And this onDataChange method gives you a data event buffer, which is basically an array of data events. And so what we will do here is just to read all of those data events and have a look at the URI, because we want to know about the URI. And most importantly, we want to know about the type. Because a data event can be of two types. It can be a change type, or it can be a deleted types. So change basically means that you have changed some data in it, and deleted, well, as its name suggests, means that the data item has been deleted from the data API, and the deletion needs to be synced on the network. So here, when I have type changed, I call my own data event changed. And when I have own data event deleted, I call my own data event deleted. So let's start with on data event changed. So we've received the data map event here on the wearable, and what we have to do is, well, to trigger the notification. And in order to do that, we just look at the URI, because I have to make sure that the URI that I was passing on my phone is exactly the same as the one as I'm receiving on my wearable. This is kind of the API between the wearable and the handheld device. And then I start reading information inside the data event and the data map object. So I get the departure station. It's like, serializing on the phone, and here we are unserializing information on the wearable side. And once you have all of those information, you can start building your notification. So the code is pretty straightforward because it's very similar to what you have on the phone. You create a notification builder, and you pass a lot of information, all information. You display, you create the notification just like you want it to be displayed. And once it's done, you notify the notification manager so that it can display the notification. And that's it. We have a notification displayed on the wearable device, just like we wanted to do at the beginning. But there is a difference between what we've done here and what we would have had if we were using the notification APIs. That is, notifications are actually not synced. So basically, if you're removing the notification here, the system will not sync the deletion between the wearable and the handheld device, because this is, for the system, this is two different notifications. So you have to take care of that manually. And this is done actually fairly easily, just by listening to on data event deleted. So here again, you listen to on data event deleted, and once you have a type deleted event, then what you have to do is basically to tell the notification manager, cancel this application. And that's it. You have the exact same behavior, because I've not presented the reverse behavior where you are deleting a notification on the wearable and you want to delete it on the phone. But it's basically the exact same code, but on the other side. So now that we have the application, we need to package it inside our application. And the good point is, if you are using Gradle, the Gradle plugin on Android, well, this is only one line of code. And this line of code is just to add a dependency to your Android application dependencies DSL. You just pass one line, which is wear app. So basically, you say that the dependency of this application is a wear application, and then you pass the project. So here, the project is actually the directory wearable. This is where the code for the wearable APK is. And by doing that, when you will build the application, the Gradle plugin will start building your wearable application, and when it's done, it will start building your actual phone application. And prior packaging the phone application, it will move the APK inside your phone application. And once you're done with that, you can publish the application, and boom, everybody's happy, and your users are smiling, and train agent too, because they love scanning the barcode. And that's it. I think we can, conclude this talk with three important stuff to remember. So, which are basically when you're creating an Android Wear application, you really have to design from scratch. Don't try, to reduce the application that you currently have for phones and tablets inside the wearable device, because it makes no sense. You have to completely start the design process from scratch. Then always think cards first. Stop thinking about a launchable application. This makes no sense on a wearable, because you don't want to interact with the wearable device. What you have to do is, display information in a glanceable, contextual way with no interaction. So always think about the notification cards first. If really this pattern doesn't fit to your needs, then you can start thinking about something else, like a wear app, as we did on Captain Train. But actually, we did that, but it's still a notification that gets displayed on the wearable device. And finally, keep simplicity in mind, because simplicity is what makes Android Wear so nice. It's all about making things simple and as rudimentary as interaction and wearable application are on those devices. And I think we're done. So thank you very much. And if you have some questions, I'm here. I think we have like 10 minutes. I think we have no questions. Anyway, if you have some questions, I will be here, so feel free to drop by. Thank you.